Howdy folks, welcome to, what is this now, part 5 or something? So anyway, so the knobs have finished drying. Let's see, which one of these did I actually repair? Yeah, no. Here we go. So basically after letting them sit for about 24 hours, the best way to get the zip ties off, because they're a little bit glued on there and they're really tight, just to get some side cutters and just cut right in between the two cracks. So just cut somewhere like that, and they'll usually fall right off. The super glue doesn't stick them on nearly as well as you'd think it would. So now that I've got all the knobs, it's time to paint them. So when I said chrome in a can, what I meant was really this stuff. This is chrome bumper paint, and this stuff's perfect for these knobs because it's designed to stick to plastic, which of course these are, and it looks like this. This is actually a clear plastic cap that the company paints with the spray paint, and that's basically exactly the finish that I'm looking for. I mean, they're a little bit yellowed because of all the grime on them, but you see the shafts on the inside, that was the original color, because that's not discolored, right? And you hold that up, I mean, that's exactly the right color. So I'm going to go outside and spray all of these, and it's supposed to dry in about half an hour. I'll give it probably a complete day just to be safe. And once that happens, I just have to fix the little indicators, because you can see they have this little black marking, which is of course going to disappear when I paint them. Now that marking I don't actually have to repaint on, because these knobs are naturally black. So all I have to do is, that's a little indentation actually, so I'm just going to get out a file or a Dremel, and I'm just going to basically scrape the paint away right there, and I'll be able to get my indicator back. So I'll go do that and let you know how it turns out. So here are the new knobs. They've been freshly painted, and I've just taken just a triangular file to notch out the paint in the indicator grooves. I think they actually turned out quite well. Unfortunately, the surface wasn't as smooth as it needed to be like mirror-like shine, and I mean, it's really impossible to get them that clean. But they're not gray. They are indeed silver. They're a little bit more matte than the original, but I don't honestly think that from a distance you're definitely not going to notice. I mean, most people probably won't notice that these have been repainted. I mean, they look a hell of a lot better than the black blotches that they had before. So even though they're not exactly the same, they're definitely way better than they were before. So I can put these on as soon as I get the chassis back together. Okay, so I just got out my only Windows computer that I still have, and the display is all messed up. The actual LCD controller is broken, so that's why everything looks blue. Anyway, I grabbed this because I wanted to try out the fact that my semiconductor analyzer has the ability to do IV curve tracing, which I've never actually done before, and you can only use a Windows application, .NET Framework application, to do it. And I wanted to see if those diodes really behaved like Zener's, or if it was just some quirk of the firmware in this thing. Now I upgraded the firmware by a long ways. Like I said, I've never connected this to a computer before, so I upgraded the firmware. It still thinks it's a Zener. I can show you exactly what it believes. So this is what it thinks. However, if I do a PN junction test, you can clearly see it does not look like a Zener. The red trace here, this is the forward voltage here in forward bias, and then this line here is the reverse bias. So clearly, if this was a Zener, we would expect to see this not being straight. So this is just a regular diode. I mean, it's not great. It's definitely not a great diode, but because it does conduct a little bit in reverse bias, but it's definitely not a Zener. So I'm not sure how their analyzing software works, but that's a mistake. So since I have my analyzer here connected to my PC, I thought I would try and figure out the characteristics of these diode blocks. Now, because the analyzer doesn't auto-detect each diode individually like it should, I thought I'd just override that manually and do some IV curve tracing. So I've just set it up to do a forward bias check. The anode and cathode are the red and the blue, respectively. So let's start acquiring and see what we get. So that's an interesting curve. That doesn't look like a diode. At least doesn't look like one yet. If this was, you know, I would expect to see a really steep. There'd be some corner point where the current goes, you know, exponentially up, but that's not really what I'm seeing here. That is unusual. Let's put it in reverse bias and see what we get there. So the current is still increasing, definitely not at as high a rate, but that's an interesting diode. That really is a weird diode, and I just pray that these things never die, because I don't know if I'm ever going to be able to find one that looks like that. I'd have to redesign that part of the circuit probably, or something like that. Let me try across the other diode in that package. I'd expect to get the same thing. Let's actually plot it on the same axis here. So it's reverse bias here, but because I reverse the leads, it's actually the same. So that's forward. So this diode obviously conducts a little bit better. And then if I reverse bias that one, these labels are backwards, you can see the line is drawing exactly over top of this one. So that's interesting. Actually, let's do for completeness, let's just move this across the package. This is when it actually did detect it as a diode, when I used the analyzer functionality. So let's do this. So this looks like it would be the forward direction, or the reverse direction, sorry, and the forward direction. Right there. Interesting. I'm kind of intrigued as to why it thinks that is a diode, but it doesn't think that is a diode. That's kind of strange. But yeah, that's a weird part. That's a really weird part. Actually, you know what? Let's put all of this all on one graph. Let's get like super high number. Let's see how many traces I can actually stick on this graph before the software gets mad at me. So this is obviously reverse biased. It's tracing right here. They're all relatively the same with respect to that. And forward bias. This one seems a little bit more lively than the rest. And let's check across the reverse of the other one. There it is right there in yellow. So the reverse, they're all very, very, very similar. But when you put them in forward bias, they're quite different from each other. And of course, as I say, that this one traces the other one almost perfectly. And then across both diodes, I mean, it shouldn't be any different. So yeah, those are the curves of those weird diode blocks. I don't know what to make of that, really. That's a bit funky. Well, I mean, they work. The FM stereo works. So unless I could find more data on them and figure out what their characteristics are supposed to be, I mean, it might be the reason why the stereo is not as sensitive as the mono, although realistically, I just think that has to do with the design, not the diodes. But I'll look into it if I can. Just thought I'd show that and you know, use this as an excuse to finally try out the software. Well, while I was looking at those diodes, I thought I'd try Googling the part number. I didn't find much until I found this. This is a service manual for a Viking console radio, and it's dated around 1963. And as you scroll through this, you know, it looks just like some old manual. And then I saw the schematic for the radio. And I said, that looks a lot like the schematic for my radio. And you keep scrolling. It's the same amplifier. It's the same radio. It's exactly the same radio. So obviously Electrohome, they probably sold the design to another company, or they just manufactured it for this Viking radio. I mean, I have no idea what kind of stuff is going on, but this is the exact same radio, and a lot of the schematic is exactly the same. A lot of the manual is exactly the same. So this is the stereo adapter. These are the dual diodes, of course. Now, one of the things that this manual has, which the Electrohome one that I have does not have, is a replacement part list. And this is really useful because it allows me to decode all of the crazy parts. And you'll notice, if we scroll down here, this is these are the two dual diode packages. Now, of course, that's not a terribly descriptive part, but it does have a lot of useful information on the other parts, which may be helpful in me figuring out what things are supposed to be and possibly finding replacements. So that's interesting. So this would be the rectifier. So obviously they had this with a probably some sort of a dual, sort of like a half bridge rectifier block, or in my case, two discrete rectifiers. Interesting. I'll have to read through this and see if I can find any differences between my model and this Viking one, because if I can't, then that means that this has a lot more useful information in it. I'll see if I can find any more cool stuff. So just quickly looking at this this new manual that I've found, I found a few things that are kind of useful. Obviously, things like bandwidth. I think the bandwidth is kind of interesting. Rather than saying 3 dB down, they say 10 times down. I think that's kind of unusual. I've never seen that before. They give some interesting stuff about the bass and treble boost and what it's supposed to do. The power output is now confirmed. It is a 5-watt peak, so that would be 2.5 watts per channel. So I was right about that. Frequency response is actually not bad. They go over crossovers and all that other stuff. So I actually used to have a radio by Viking. Now that I see the Eatons on this, I remember I had a little portable transistor radio by the name Viking. So yeah, now this actually rings a bell. So this was probably around the same time. So I think what I might do is I'll just for shits and giggles, I'm going to take these dual diodes out of circuit, and I'll actually just put in some modern, like I don't know, 1N4007s or something, and just see what happens. I want to see what the performance of the radio is like with a modern diode. It could not work at all. It could work amazing. I just want to know exactly how critical this circuit is. I might analyze the circuit and just see if that'll work before I take them out. But it's not a lot of work to take them out and put some new ones in. I've got a whole bag of them, so I think I might try that near the end and just see see how it performs with modern diodes instead of these weird, probably impossible to find package diodes.